WorkXplore is a powerful 3D viewer and solid model analyzer. As can be viewed here in the drop-down menu, it allows you to open a vast array of models from various CAD applications. Direct from an integrated Explorer, the Siemens JT file is dragged and dropped into the workspace, where the model is automatically zoomed. The CATIA and IGS files are effortlessly loaded and assembled also. Next, and for efficiency, the STEP, Parasolid and SAP files are group selected and opened in reference to the datum. Zoom and pan and rotate are all controlled via the mouse, and even the most complicated file can be decluttered using the Assembly tab. Hiding and showing individual models, simply click the model name within the tree structure. A simple right-hand click over the model yields the pop-up display menu, where a variety of view commands can be easily accessed. Here we see the hide, the show, colour and transparency controls. The software is using standard Windows functionality, making it easier to use and lowering your learning curve. Customers working in the aircraft industry will particularly benefit from not only being able to load the latest CATIA model, but the extra ability to load point data and geometric dimensioning and tolerancing features. WorkXplore allows users to easily share their projects throughout the entire design and manufacturing chain by offering a cost-effective client viewer. Once loaded and saved, the WorkXplore file can be exported in a variety of formats. Even non-expert CAD users can quickly get to grips with WorkXplore measurement functions. Here we see the annotation commands. The radius, point-to-point and Z-plane positions are recorded and displayed. The model is picked, the annotation automatically appears, and the user then slides the dialog box into position. On the top left of the window, the heads-up display is used to effortlessly manipulate the view. The layout is altered at the click of a button. Here we see the screen being split into two, paving the way for further dimensional annotations. Although the views are independent, modifications are dynamically updated throughout all windows. Further information extracted from the model using dimension functions. The dialog offers numerous styles of dimensional input. As the annotation information is required by other departments throughout the organisation, screenshots can be created in a variety of methods. Each image is stored or collected. A hard copy can be created and saved by way of a JPEG file. These files can then be distributed throughout the organisation. WorkXplore also offers a range of analysis functions which are usually only available with more costly CAD solutions. Draft analysis, as we can see here, calculates and displays angles and undercuts and then rapidly processes the model by colour coding. Precise draft angle values are displayed dynamically as the mouse is dragged over the surfaces and can be inserted by default in the 3D model. The angular value is anchored to the model, and again the data can be saved to either a project file or, as we saw previously, a JPEG. Solid curvature analysis detects and displays radius, fillets and other curved faces. It is a valuable tool allowing engineers to understand the model more clearly, thus enabling fast cost and production time evaluation. The colouring of elements to be analysed is automatic, and users can insert measurement labels containing precise values of the elements selected. With WorkXplore, the user can either view concave, convex radii or both. Again, the whole design can be saved out as an image and shared throughout the organisation. The thickness analysis function can be used to highlight critical zones on mechanical parts. Values are indicated on a colour scale, which can be represented by coloured bands or progressive colour changes. There are 3 levels of precision to determine analysis speed and quality. Users can also obtain information about thickness at a specific point by clicking on the model, as we saw with the previous tools. This tool is particularly useful when machining parts with thin sidewalls, where potential cutting forces can warp the pocket structure. Plane face analysis produces an instant coloured representation of the topology of the model. This is useful when considering the machining method of a part. Do I use flatland cam cycle or do I use a waterline cam cycle? A simple click on each of the faces displays the Z position of the face. Here we see face information, creating information on objects and surfaces, enabling rapid calculation of volume and areas. Complementary information such as the object name, encumbrance, number of faces, etc. is also available. One may use this information when, say, calculating material and time costs when electroplating the part. You may notice a common theme running throughout all these analysis tools, and that is information. The more data that can be extracted from a model, the more intelligent and informed manufacturing decisions can be made. We see this now with the mass properties. Here we not only see the centre of gravity, but we see information such as weight, volume and area. A user can create their own library of materials, which includes density, and thus weights can be calculated. This could be used to plan loading capacity for a machine tool, or cost of shipping a product. Compare Models command allows you to confidently predict the surplus material between files. This could be used to compare casting against the finished part, or if and when there is a design modification, to compare the before and the after model. The modifications are clearly identifiable by colour to distinguish material added from material removed. By clicking on the model, the user can measure the difference between the material and the model. A simple click and slide the information dialog into a convenient position. Moving along the toolbar, we meet the automatic measurement command. Even non-expert CAD users can quickly get to grips with the software's measurement functions and immediately obtain good results by making use of the software's predefined selection modes: points, wireframe, entities, planes, surfaces, etc. Straight from one single dialog, a user can choose either single or multiple entities and produce endless annotations around the model. The software intuitively picks the measurement positions. Again, a simple drag and drop positions the dialog. We now come to the dynamic section command. The most complex of components can be easily understood by literally peering inside the guts of the model. High-performance dynamic sectioning allows users to control the section plane with the mouse or the dialog menu in rotational and panning directions. Grabbing the orbit or the axis marker, the user can push or pull the vector to dynamically section the solid model. Using the Retrieve the Section function, a user can automatically create the cross-sectional profile on the 3D model or as an isolated entity. Sections are displayed in the Assembly window. These profiles can be extracted and exported by the DXF and DWG interfaces. Furthermore, the profiles can be used to plot toolpaths or can be individually analysed independently. Finally, we see what some would argue is WorkXplore's strongest feature: animation. Assembly models can be brought to life by adding a vast array of movements, and once added, the command can also detect collisions. The animation dialog is like a timeline, with all the events clearly displayed. Here we shall add a new movement. Down the left-hand side are the items making up the assembly. We've selected the base, and from the simple menu we begin to add the movements. A specific name is assigned to the movement. The type of movement is added: translation, rotation, through to helicoid. Travel amount is added, in this case in millimeters, and also along which axis. You may edit the command, amending the movement, or as in this case adding rotation movement to the base. 2000 degrees in the Z axis. Again, the command can be previewed, and we simply slide the movement along the timeline to determine when the event takes place. We use the play command to test the overall animation playback, and if we're not happy, we can correct the movement on the base, reducing the translation amount. Now we play the overall effect. Thank you for watching this presentation of Hexagon's WorkXplore.